Hi, I'm Caleb from Timpson, and today we're going to talk about types of transformers. So there's a few different types of transformers. It's very common in this industry, and we're going to talk about all three of them and the uses and where you might use one as opposed to the other. So the first one we're going to talk about is an isolation transformer. And one of the questions that you might get asked at a journeyman test is, are the primary and secondary coils of a transformer electrically connected? Right? And of course, the answer that they want you to say is no. But if we look at a conventional type transformer, say a single bushing top like this one, if we look at this primary coil, it's coming in and it goes out to that little stub, or sometimes it goes to an H2 that gets grounded. And then our X2, you have your coil like this, and this also is grounded to the case, and these both get grounded to the neutral. So by all intents and purposes, those two coils in that transformer are electrically connected through the ground. Now, the benefits of this conventional type transformer right here is that we can hook it up to single phase. You don't need two primary phases. It's cheap, easy to make, easy to hook up. The downfalls of it are if you have a power surge on the primary side, the core of this transformer that gets magnetized negative, it doesn't saturate. And what I mean by saturate, and I'm not going to get into the science deeply on this, but the core of a transformer, when it saturates, that means that it can take no more magnetic field, and the magnetic field in the core itself starts to collapse. As the magnetic field collapses, the impedance of the transformer goes way up. Remember, these types of transformers right here are low impedance transformers, meaning that if you have 1.2% impedance, it's a 25 kVA transformer. If you have a 25,000 watt load on that transformer, you have about a 1% voltage drop, which is pretty good, very efficient. If the impedance goes up 50%, say, and you have a 25,000 watt load on that transformer, what you have is a 50% voltage drop. So with these, the core does not saturate. It doesn't saturate very easy at all, meaning the higher I step this voltage up, say if this is 7200 volts and I step that up to 10,000 volts, well, your turn ratio remains the same. If it's 30-1, 10,000 times 30, you can see where the problem lies. That power surge on the primary side translates right down through to the secondary side. Vice versa. Now, let's talk about an isolation transformer. A very common type of isolation transformer you're going to see in the field is a delta transformer. And I've said this the other day, there's a lot of, you have 4160 delta, you can have 12470 delta, you can have 25 kV delta. It doesn't matter. But if we look at the delta transformer, your coil goes like this, and this might go to A phase and B phase. Then your secondary coils. Now these two primary and secondary coils are entirely isolated. So your magnetic flux that's traveling through this core is all just that. There's no electrical connection to help make a perfect highway to carry that fault current and that power surge through. This core saturates very easily. On an isolation transformer, if you put a power surge into this top side, it saturates the coil very quickly. So you end up getting a low voltage out of the secondary side. A good place for isolation transformers would be if you have 34 kV overbuild over top of 12 kV. That would be an excellent place to have isolation transformers. That way if the 34 comes down and touches the 12, you don't rocket meters off the side of houses. Another good place for isolation transformers that you'll see is in facilities that have a lot of really sensitive equipment. Us being the power company or the contractor, we'll feed the power into the building, and then inside the building, they'll have a 1-to-1 ratio transformer that intakes the same voltage as it outputs, but it's isolation. So there's a complete separation between coils. That way, if there's a power surge coming from our side, it doesn't damage their equipment. And oftentimes they're hooked up in a Y configuration. They just float the Ys on one side or the other. So the conventional transformer, easy to put on single phase in the backyard, cheap, readily available. Isolation transformers, typically you're going to need two primary phases when you're in the utility industry. at least. So single phase now has to be 2-phase. Regulators. So the regulators, obviously, this transformer is a little bit different from the other two. So if we're looking on the inside, unlike these where they have a primary and a secondary coil, a regulator only has one coil. So if I erase this picture and show you what's happening inside. So let's just make one primary coil, and we'll take this bottom side of the coil and ground it. That'll go to neutral. You'll have a mid tap here where your 7200 volts is going in. And then on the sides of these coils, you have little taps sticking off, up and down. Your 16 positions each way. And as that tap changer changes, it's moving from here, and this is neutral. So if your tap changer was right here, your neutral light would be on, the regulator bank would be in neutral. That's when you could bypass it. Regulators, we're going to do a whole nother video on regulators alone because they can be very dangerous and tricky if you don't know what you're doing. So if you come down here, there's less coil between the neutral and here, your voltage is going to step down. If you come up here, there's more coils, your voltage is going to step up slightly. It's worth saying that regulators are a great and easy way to regulate voltage on long runs of voltage drop. What they're not good for is stepping down voltage 30 times. The rule of thumb is you can do 2 to 1 with a regulator, and that's because we were talking about those power surges. Power surge coming through here has to be able to magnetize that core at the same rate that that power surge is happening, which doesn't happen in an isolation transformer. It does happen in here, but it's limited by how much pressure that transformer can take. Here, it makes a perfect highway because it's attached permanently through a coil. So if your tap changer's up here, you're boosting halfway and you get a power surge, it goes directly through. So you wouldn't want to take and step your transmission voltage down from 230 to 1247 with an auto transformer, which is what a regulator is. It's a type of auto transformer because if there was a power surge on the transmission, it would be absolutely catastrophic for the substation and the customers fed off of that substation. Now there's one more type of transformer. We're not going to get into it too much, but it's a current limited transformer. A current limited transformer means they're 100% impedance. So if you had a 7200 volt transformer and we had it set at 25 kVA, that means if you put a 25,000 watt load on there, you would have 0 volts coming out. If you have any questions on transformers, or you want any more information, reach out to me. Leave something in the comment and I'll get a video out. So thanks guys.